I'm not going to use any slide decks at all. And the reason for that is I feel that the demonstrations will probably give you a little bit more clarity and context around some of the capabilities of these services. And of course, make that important decision of when to use which service. Okay. All right. So we're going to talk about containers. Now, I'm not going to spend any time talking about why containers and blah, 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 because if you're joining this session today, I am assuming that you have some foundational knowledge of containers. Having said that, I do want to point out that choosing containers should not be because, hey, you know what, I could basically bin pack 20 containers on that physical host instead of just running 5 virtual machines. Well, density should never be one of the reasons why you should choose containers. One of the most important benefits that containers offer is the ability to maintain the same state, the same experience that the developer has, no matter where that particular container platform runs, right? So whether it runs on premises or on Azure or any other cloud vendor, the experience remains the same. And that consistency is one of the crucial factors why customers embark on this journey. Now, containers are great. For example, let's say, you know what, I want to run an Apache Spark cluster on my machine. And if I just navigate to the documentation and start downloading all the binaries, including Java, JDK, then I need to go and download the Spark JVM. Then I need to basically go ahead and configure a bit of environment variables. I can simplify that entire process by running a Spark container. If you want to do a build of a application and you need a Jenkins master slave cluster, you could do so running containers instead of just running it on the host machine. That's one of the reasons why typically customers choose containers, the ability to have that consistent deployment and development experience, right? Now, choosing to run a single container is pretty straightforward. It's easy. Now, as we embark on this journey of microservices architecture, one of the common challenges you typically face is I have so many containers, so many services running in my environment. How do I streamline the communication between them? How do I basically orchestrate them? And therefore, as a result, and hence, we have some container orchestration options within Microsoft Azure. You could typically choose to use Kubernetes, and I know Kubernetes is going to be a hot topic for today's session. I'm going to definitely talk about that. But you can also choose other options which may fit the portfolio of applications that you're currently running. But not only that, the skills your end users, your developers might have. Not everybody here is a Kubernetes expert. And if you're one of those, you don't have to decline the strategy of using containers just because you don't know K8s or Kubernetes. You could still use some of the services that we offer to orchestrate containers without going through documentation and becoming a CKAD or CKA, so that's for that matter, to run your Kubernetes or to run your container platform. So that's something that you will see in action today. And finally, we'll talk about one of my favorite service that's currently in preview. We'll talk about that in detail, but that basically abstracts that Kubernetes environment for you, gives you a serverless Kubernetes and the experience or a very simplified experience of not only developing applications, but also deploying, scaling, and managing revisions and such, and all those cool factors that you typically expect for a cloud native application platform to behave like. All right. All right. Enough of talking. Let's get started, right? For the purpose of this session today, I'm going to use a Docker container image that I created, and it's called the My App container. Now, it's not groundbreaking, doesn't really have any microservices architecture here, because what I really wanted to focus on in today's session is the orchestrators, the container services, rather than focusing on the actual container. And as we go on, if you have questions, please feel free to put them into the chat window. Now, this is a public container image. It's available in my Docker Hub. And I'm going to basically pull this image down, show you the application, and then let's go ahead and try to use some of the Azure services to host this particular application, right? So here is that particular application. You can see that this is Docker pull. Now, if you look at the tags here, it basically has 4 tags. So right here, you'll see there is version 4, version 3, version 2, and version 1. And the reason I have these tags is because each version basically demonstrates one capability of that application. So you might have version 1 in the blue color, you might have version 2 in the yellow color, this 3 in the green color, and so on and so forth. So we can distinguish between different versions of that applications. And this will come handy when we start looking at the ability of a platform to offer changes at the go. All right. All right. So this is what we're going to start off with. And I'm going to just quickly go ahead and run a simple Docker container based out of that image, right? Now, I do have Docker for Windows installed on my machine. And if I just go back here and double click on my Docker icon, you will see that this is that Docker for Windows running. I think it's currently version 4.6.0. And if I look at the settings here, I've also turned on Kubernetes on this particular machine. In fact, Docker for Windows makes it extremely simple to basically have a single node Kubernetes cluster up and running on your host machine. Okay. I'm also using WSL2 as my backend instead of Hyper-V. This is basically using that engine to empower or to run those containers, Linux containers that I'm going to create. This application here, Manoj My App, is a .NET application, and it's running on a Linux container. All right. So let's go ahead and with that, let me first validate what version of Docker I have. So I'm going to do a Docker version, and you will see that this is currently running version 20.10.13 in the client side. All right. Now, since I've also enabled Kubernetes, I can simply run kubectl, as you probably know, the kube or kubectl, whatever way you pronounce it as. I can use the version -- short, and you will notice that here I'm running the latest version of Kubernetes, which is version 1.22.5, both from the client and the server side of things. All right. Beautiful. Now, let's go ahead and run that Docker container. So I'm going to run Docker container run. I need to specify a -d because I want to run this as a daemon service. And what I'm going to do now is to specify the port number. So I'm going to map port number 8080 of my container, or of the host, in fact, to the port 80 of that container. And I need to specify the name of that image that I want to pull. So that would be my app :v1, right? It's case sensitive, so making sure that that is v1. All right. Now I'm going to hit enter here. So this is actually, if I can spell Docker correctly. So let's go ahead and change that real quick. Docker, can't type today. All right. So you can see that it's unable to find that particular image locally. So it's going to go back, pull down that image from the Docker Hub repository. So it's going to pull those images down. Now, one thing you might probably notice, so if you're new to the world of containers, this layered approach has a significant benefit in terms of saving disk space. So imagine that you want to run two web servers, one on Nginx and the other on Apache, and both these web servers use Ubuntu as their base image. And you've already downloaded the, let's say, the Nginx image. You don't need to download the Ubuntu image again because you've already gone ahead and downloaded that as a part of the structured layer approach, this auxiliary file system that you have within containers, right? That's one of the beautiful aspects. And only the topmost layer is a writable layer. So any changes that you make essentially adds a layer to that particular container image. All right, so my container is up and running. And if I just want to validate that, I'll just do a docker ps-a, and I'll see that that particular image or container is running. It's running the command .NET myapp.dls. It's a .NET application. And I'm running this on port number 8080. So if I navigate back here to a different tab here, and let's type in localhost port number 8080, that's that $1 million web application that I created. And as I said, it's not groundbreaking, but it basically tells me information about the machine name on which it's running. And you'll notice that this machine name is nothing but name of that Docker image or the container that I'm running. And it's also saying that, hey, this is actually running a containerized version, an application that's running on a container. And that's version 1.0 of my application. Great. So I'm happy with this application now. And I want to now go ahead and start using or consuming some of the Azure services to host them. Now, you are totally fine to use a Docker Hub as a repository for hosting your container images. That's totally fine. However, from Microsoft, we have a platform called Azure Container Registry, or ACR. And what ACR allows you to do is to host those images. Now, you might ask me a question, Manoj, I already have a Docker Hub. Why do I need your Microsoft Container Registry? And that's actually a good question. Let me answer that in just a moment. Docker Hub is great. But if you want to make sure that you have a private repo which only contains images that you want to expose only to certain organizations or for your organization, in such scenarios, you typically have to go with a paid model. Not only that, if your backend infrastructure, if your compute workloads are going to run on Azure, wouldn't it be great if I can host the container images within Azure and they can be securely accessed within those virtual networks, those networking paradigms that I have within Azure? And not only that, I can use secure identities to connect to that ACR repository, which is the Azure Container Repository, and download images. without the need of using username and passwords and credentials and configuration files and stuff like that. That's one of the advantages of using Azure Container Registry. And to do that, I can navigate to the Azure portal. And here I can click on create a resource. And right here, I can go to containers and choose to create a container registry. So you can see, you can see there is a container registry here. I'll give a click on create that. And what I really wanted to show you is that you can define the name here. So that name is globally unique. Let's call this reactor ACR 001. All right. Now, what is important here is obviously the location. So in this case, I'm based out of Australia, so I can choose Australia East. But the most important decision criteria here is to choose the SKU. Now, in simple words, the premium SKU gives you the best of all worlds. So, for example, the ability to replicate your Docker images, I should say container images, from one region to another. Now, imagine if you have a disaster. Let's say you host every images or every Docker image or container image in Australia East, Sydney, and Chuck Norris attacks Sydney, right? You need to make sure that you have a backup available somewhere because these are your mission critical applications. So you can basically add additional global regions as a part of that, and the replication is taken care of for you. It also gives you some capabilities like trusted content. You can actually use webhooks and stuff like that, okay, which I'm going to show you in just a moment. So right now, we will be using this ACR, right? To save time, I've already created an ACR. So if I go back to my resource group, let's click on OK. And here, let me go to this RTO RG01 resource group. And you will notice that I have this ACR or Azure Container Registry. And this one here is a premium SKU. And because it's a premium SKU, I can take advantage of replicating this across the globe. So that's what I was talking about earlier. So I can say that, hey, you know what? I want to replicate this image between these different regions. And I can just go ahead and add those regions here. Not only that, I can take advantage of webhooks. So each time I make a push to this repository, I can run a webhook that can probably call an Azure function that performs a bit of validation, so to speak, on those pushes as well as on deletes. So you can take advantage of all these capabilities. And of course, finally, you can also take care of content trust, which is actually very, very important. Especially in scenarios when you have those images and those base images may potentially have a vulnerability. In such scenarios, you can take advantage of this content trust feature. All right. So right now, if you look at my repositories, I don't have any repos here. But if I go back to my overview, this is indeed that login server that I have. Okay. So instead of using Docker Hub, now I want to use this. So I'm actually going to go ahead and copy this to my clipboard. Now, because I've already pulled that image here, let me hit Control L to clear the screen. Now, if I do a Docker image ls, right, you'll see that it displays all the Docker images that I have. Let me actually pipe this to select string Manoj Nair. And you will see that I have this Manoj Nair, my app, with the tag of v1. All right. I'm going to basically go and tag this with the name of that login server. That's the requirement for basically pushing this to that particular repository. However, before doing that, I obviously need to authenticate myself to that ACR. And because I've already logged in to Microsoft Azure using my Azure CLI, I can basically use a command within the ACR subgroup to log in and authenticate myself to the ACR repository. Okay, so the way it's done is if I just make sure, first of all, that I've actually authenticated to Azure, I'm going to say AZ account, if I can spell account today correctly. Sure. So this is my Azure account. I'm successfully authenticated to the Azure account. Great. And now I'm going to run AZ ACR login. And I need to specify that name of that login server, the name of my Azure Container Repository. Now, what this command actually does behind the scenes is use the Docker login command and use the Docker login command. Sorry, I can't speak today. Docker login command to authenticate to that particular remote repository. So you can see that it's already done and my login is successful. Beautiful. Great. Step number 2, we need to basically now tag that Manoj Nair my app v1 image with the login server name. To do so, I'm going to use Docker tag, and I'm going to specify the name of that particular image. This is, in this case, Manoj Nair my app v1. And I'm going to tag that with the name of that login server / my app v1. So I'm expecting it to create a repo called my app with a tag v1. All right. So that's what it's going to do. So the Docker tag is successful. And all I need to do now, because I'm successfully logged in, I'll use a Docker push command to push it. So right now, we even haven't reached the stage where we've started deploying our container images on Azure, but we have hosted that container image in Azure. So we now have a secure place essentially to download and upload our Docker images. All right. So this is almost done. We can see that it's almost pushed all the layers. All right, beautiful. So we get that digest back. Now, if I go back to my repos, you will see that here we have that my app repo, and here is where I have my tag. Okay, so you can see that this is the command that I can use to basically go and download that particular images. All right, beautiful. Now, what is also interesting though is if I go back to that my app repo, all right, and if I look at this here, in fact, go to my app, you will see that there is an ability for you to create a webhook. Now, this is really interesting because the kind of possibilities it opens up for you to make invoke a function or a logic app, so to speak, whenever somebody makes a push or a pull or whatever it is gives you a lot of control on how you want to validate your approach towards containers, right? So in this case, let's say that I want to give it a webhook name. I'm going to call this my webhook for lack of anything interesting. It's going to be based out of Australia East. Now, I need a service URI. Typically, this would be a post request that gets sent to one of your Azure function front-ended via Azure API and service. That could be one option, right? But since I don't have one, I'm going to take advantage of a website called webhooks.site, if I remember that correctly. In fact, that's not the one. So webhook, let me just search for that real quick. I'll bring that link here on the screen. Oh, it's webhook.site. So if I go to webhook.site, yeah, this is a link that actually I can use to test if I want to send any data to a custom webhook, right? So this is my webhook URL. I'm going to copy this to the clipboard. And if I go back to that page where I'm creating the webhook, I'm going to provide this URL here. Of course, I can give some information. I want to do this on push, and I want to scope it to every container tag that I'm going to push or image tag that I'm going to push to this my app repo. All right. So let's go ahead and create that. All right. So it's going to give or create that webhook. Now, once I have that webhook, if I go back here, and in fact, let's navigate to this portal here. In fact, right now, it's still waiting for any request to be sent. But if I come back here and go to my terminal, and let's do a push again. Now, obviously, we have already pushed that image, and we have not made any changes to our image, so nothing should happen. But because we made that push, notice what happens to your webhook site. It gets that data. Now, I can actually consume this data and perform actions accordingly. So that's the advantage of using webhooks whenever you want to push those Docker images, so to speak, on the Azure Container Registry. All right, beautiful. So we have the image on an ACR or Azure Container Registry. Great job. Now we need to host them. All right. If this is going to be a single application, an application that you just want to run without the need of installing a container runtime, so to speak, on an Azure virtual machine, you don't want to manage the virtual machine, the patching and stuff like that. I just want to run a single container image, so to speak, and I want to run it serverlessly without the need of me installing, container runtimes. I can take advantage of a service called ACI or Azure Container Instance. An Azure Container Instance is basically defined for those customers that want to run those containers without the need of an orchestrator, so to speak. You just want to run one web application, a build server of Jenkins, maybe a file server for an application using a container. That's all that you want to run, right? A web application, so to speak. And you don't want to run or orchestrate that as such. ACI is a great component. And let's take a look at how ACI looks like. So I'll go back to my resource group and let's click on create. And I can choose to go to containers and I can choose to run container instances, right? As soon as I click on create here, you will see that it gives me the standard experience of blades and journeys. Let me give this a name. I'm going to call this Reactor ACI for lack of anything interesting. Again, let's deploy this in Australia East. And you can see that you have to choose an image source. Now, this image source could run anywhere. It could be on Docker Hub, as you can see. It could be on Azure Container Registry, the like one we used, or it could also be on other registries. Okay, so this could be, for example, a public registry like Docker Hub. I've already showed you an example of Manoj. So you can see that if you just go back to Azure Container Registry, by the way, it picks up my ACR. Now, please remember that as a part of this portal, certain permissions are assigned to ACI to pull those images, right? You can actually, there's no magic here. ACI doesn't automatically get permission to download images from any Azure Container Registry. It needs permissions, and you can do so using things like manage identities and service principals behind the scenes, okay? But the portal will give that particular permission. I'm going to actually choose other registry because I just want to show you the other example here. So I'm just going to type here Manoj Nair / my app v2. Let's use the version 2. This is a Linux version, and you can change the size, so to speak. Now, also remember that you can also choose to create or provide your Docker Compose files, in fact. So if you have a Docker Compose application that uses a Nginx web server that talks to a PostgreSQL database, you can provide that file here. That's currently in preview, by the way. All right. So I'm going to hit networking. Now, this is a long ask, so to speak, long request from our customers. And they really wanted the ability to have your container instance to be exposed only within the premises of a virtual network. And you can do that today by using this option of private. By choosing private, you can basically say that I want to make this container instance only to be available within a virtual network, maybe to your on-premises organization using the express route connection. All right. But in this case, we'll choose public, and I'm going to call this my app v2. And of course, we need to open up the required protocols. So whether it's 80 or 443, depends, doesn't matter. In this case, my container application is actually running on port number 80. So I need to open those ports here. I can choose to go advanced, and you can specify some environment variables that you can consume within your container instances, any overrides that you want to do, which will override the command that gets started when you instantiate your container. All right, let's click on review and create. Now this is going to go ahead and run the final validation. And once the validation has been completed, I can go ahead and click on create. So what is this going to do behind the scenes is going to create a virtual machine that you don't have to manage, that we will manage from a Microsoft perspective, and give you the ability to give you this particular container up and running. Now, remember, this is a public image. So this URL, so to speak, is something that you should be able to access once this particular application gets successfully deployed. All right. So we'll just give this a couple of seconds for it to go ahead and deploy. While we see this deployment in action, I'll just quickly pause here and see if there are any questions, Michael. Looks like we don't have any questions. Beautiful. Let me go ahead and see if this deployment is done. Now, as we wait for this deployment, I want to talk about another option for you to deploy your containers. And we saw a use case where a single container image deployed using ACI could be one of the options, and that one has successfully deployed. So I'll just quickly go to the resource here. And this is my FQDN. So I'm going to copy that, open up into a browser, hit Control V. Now you see that this is my version 2 of the application. Beautiful. So if I just wanted this to be up and running, maybe for a community event or maybe a sale event that's happening just for a couple of days or maybe a month or so, this is a great choice. Right? I don't need any orchestration experience. I don't need any containers experience. I just need a container, and Microsoft will host it for me. That's the beauty of Azure Container Instance. There is actually one more use case of Azure Container Instance, which we'll come back to when we talk about the AKS or the Azure Kubernetes Service environment, right? All right, so this is one experience of one way of deploying containers. Now, there is no orchestration required here. There is no orchestration at all, so to speak, right? There's just a single image running there, maybe a Docker Compose file that's running with multiple images. But remember, technically, this is running on a container group. If you come from the Kubernetes world, this is a container group is similar to the concept of a pod, where all the containers within that pod will share the same resources. Okay, so it's basically running on the same host, same resources. So if you have a container group containing of a web server talking to a SQL database, both these containers will be running within a same server. And for me, as a developer or a sysops guy, I don't have to manage any of that underlying orchestration for me. It just runs it for me. Great option. But now imagine a scenario that this application becomes the next Pokemon Go. And in scenarios like that, how would you basically scale up and down your application? That's where you can take advantage of some of the orchestration services that we have to offer. One such orchestration service is very popularly known as our Azure App Services. So if I go to back to my resource group here, let me create a new resource. And at this time, I'm going to create a web app. Now, you might wonder, Manoj, I thought that web applications was typically used to run those runtime-based applications like .NET, Java, Python, Ruby, blah, 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 containers. And the valid reason to create containers on Azure App Services is when your team members, your team that basically runs and deploys this, wants to take advantage of some of the capabilities that App Services has to offer, which is including auto scaling, but more importantly, it doesn't really have that container orchestration skills as much as they would in typically environments like Kubernetes and stuff like that, right? So imagine that you have an application that you could Dockerize or you could containerize, but now you have to go through this painful journey. In fact, I should not be saying painful, but a very interesting journey of learning and mastering Kubernetes or any orchestrator of. Sorry.
No, you're right. If I could just pause you, there was just two questions that might be relevant to this. So one was, which command line tool are you using? And then the second one is, what if we want to scale the containers?
Oh, great question. Let me answer the first question. I'm using Windows Terminal and I'm using Oh My Posh, which is, I'm using a PowerShell engine here. So this is running PowerShell version 7.2.2, which is the latest stable version of PowerShell Core. And I'm using something known as Oh My Posh. So if you've come from a Linux background, you know there's something known as Oh My Z Shell. Oh My Posh is a PowerShell implementation of that. Happy to share you the config commands that I've used to get this look and feel. If you're interested, just hit me up on LinkedIn and I can share you those config files. Now, the second question, which is very interesting, how do I scale those containers? There are few ways if you want to scale your containers, if you're planning to host them on ACI. That is, you have to subscribe to events. Now, that is pretty complex. And that's why I'm coming to this particular point where you can actually scale your containers easily using Azure Container Apps. And I'm showing you that in just a moment, right? So in this case, I'm using an Azure Web App Service. So let's just choose the resource group and I can give it a name. So let's call this RTO Web App 001 and it'll check if that's particularly unique. But typically you run this. You choose to run your applications based on a stack. So whether it's .NET 6, whether it's Java 11, Node.js 16, LTS, doesn't matter, right? That's the experience that you use for web apps. But now in my case, I have a container. So I can choose to use a Docker container. And by choosing to use a Docker container, the application service plan, the app service plan, ASP behind the scenes, now uses a container runtime on that particular platform to host and run your containers. Now, if you want to scale, let's say your application becomes the next Pokemon Go, and you hit more APIs, you make more requests per second for your application, and your CPU utilization of the underlying host goes berserk, or the network traffic goes berserk. You basically can then create auto scaling rules to spin up another host on which your container will run. Now, in the case of app services, all right, the container will run on every host as long as you want to scale. So you have a copy of container running on host 1, host 2, host 3, if you have 3 hosts running. Unlike in the world of Kubernetes and some of the other orchestrators where you can actually bin pack them to specific hosts, in the case of app services, it just scales. It just runs every instance of your container across every fleet. Now, if that sounds to be a problem, it is actually not, because remember, you can choose to define what level of performance you need by choosing the different app service plans that you have. Now, remember, it's doing all of these automatically for you by using the app service auto scaling rules, right? So in this case, if I choose to use Linux containers, I want to deploy this in Australia East. And this is what I was talking about. You can define your plan. So based on the plan, you get specific number of instances, and you also get the ability to define how much CPU and how much memory you have to have on that one single host. And you can scale between 0 to 20 instances or 0 to 40 instances, depending upon the plan that you choose. All right. Now, let's say you choose to go with P1 V2, you can choose to upgrade that to P2 V2 in future as well. But having said that, you also have the ability to tap into some of the benefits that app service has to offer. And I'll show you that in just a moment. So in this case, I'm going to choose P1 V2, which basically gives me the ability to auto scale this up to 20 instances. Beautiful, amazing. Okay. So I'm going to click on apply. And then I'll just click on this zone. By the way, you can turn on zone redundancy basically if you want to take advantage of availability zones. In this case, that's not something that is interesting. In fact, let me go to previous and I'll just make sure I have everything available. Yep. Now, in this case, I want to run single container. You can choose to run Docker Compose as well. Again, this is in preview. I'll choose to run single container, and I'm going to go with maybe a Docker Hub repository. This case, we'll choose our Manoj Nair / my app v3, the third image, the version 3. And I don't need any starting commands here. So let's click on monitoring. You can integrate with something known as Application Insights, which is an amazing tool if you are planning to run your workloads on Microsoft platform. The kind of telemetry information you get, especially when you run a microservices architecture where you have to keep a track of these distributed transactions that go around the place, Application Insights is a great platform. Okay. In this case, I'm just going to turn it off for simplicity, and let's click on review and create. Does the validation. Remember, we are using P1 V2, and I'm using the version 3 of my image. Now, you saw that there was one option to choose Azure Container Registry. So you can see that basically your web app can tap into Azure Container Registry. Now, I told you that there are certain benefits, so to speak, that an Azure App Service has to offer. And most of my customers who basically use Azure App Services is because they don't want to spend their time writing stuff that's least important. That is writing the CI/CD pipelines and making sure you have a traffic shifting pattern, so to speak, where I can say 80% of the traffic goes here, 20% goes there. I don't want to manage these deployment slots. Let the application platform do it for me. And one such example here is that right now I haven't configured any deployments, but you can take advantage of these continuous deployment. And this could be basically a source code that includes a Docker file running into from a GitHub repository. And you make a change to the Docker file, it spins up what we call as a GitHub workflow. And that GitHub workflow will use GitHub hosted runners or self-hosted runners to basically go and do the build and then deploy this back to your app service environment. Okay. So let me actually go ahead and create this. So this should go and initiate the deployment. Now, as I said earlier, what this basically allows you to do is to take advantage of that app service platform. So if you ask me, Manoj, when should I use Azure App Services or web apps for containers? The ideal use case is if you already have some investments in app services and you don't want to basically time, or you need some time to ramp up your teams on other orchestration services like AKS or for that matter, ACA or Azure Container Apps. In such scenarios, you can take advantage of the Azure App Services. So you can tap into some of the benefits that app service has to offer. You get all those benefits along with the ability to even route your networking traffic. So if you've been abreast with some of the changes that we made with app services, essentially you can take your routing, make it route through an on-premises gateway. If you have those security requirements, you can take advantage of private endpoints and have a private IP connectivity, so to speak, to your web apps and stuff like that. So you can see that that resource has been deployed, and you can see that now I get all the standard benefits that app services has to offer, including the ability to add authentication, a single click authentication mechanism to say, hey, I want to make sure that this web application ensures that the user is authenticated with an Azure AD account, right? So all these features, including deployment slots, so to speak. Right now, I only have one slot, which is the production slot, but you could basically add multiple slots here as well. In this case, if I go to my deployment center, I can even integrate this, so to speak, with one of the GitHub repositories. So in this case, you can see that this is the registry settings, and I can use things like GitHub Actions and builds or even pipelines. And you know what's the best part of this? It actually writes that entire action YAML for you. I mean, that's really amazing. It's beautiful because what it allows you to do is if you're doing this on a test environment, you can repurpose that YAML file for your production applications by just making a few changes. Of course, knowing GitHub Actions and YAML files would be even better, but just wanted to say that. All right, so you can see that this is done here. And in fact, let's go to overview. And this is the URL here. I'm going to copy this up and go back to the same URL. This was version 2, which was running on ACI. Let's hit here, enter. And now you can see that this is version 3 of my application. And it is obviously secure using HTTPS. You can have custom domain names depending upon the app service plan that you choose to use. All right. So this is app services. You don't have any content orchestration experience. You don't have AKS experience. You just want to make sure that, hey, I want to have applications hosted on Azure securely. I want to take all the advantages that the typical app services environment has to offer me, including the ability to auto scale based on demand. So you can have those auto scaling rules created for you, where you can choose to define, hey, whenever I hit CPU utilization of 80%, I want to add additional instances, so to speak, within my server farm or your app service plan, right? All right, this is app services. Now, if you do have Kubernetes experience and you're well versed with Kubernetes, you can now take advantage of AKS or Azure Kubernetes Services, right? With AKS, essentially, it's a managed Kubernetes cluster, which means you don't have to install the master node or the worker node, so to speak. We will do that for you. We will use instances behind the scenes to get that up and running for you. The control plane is something that is completely oblivious to you. You only focus on your environment. You create your pods, your deployments, your replica sets, your Helm charts, so to speak. We'll make it easy for you to even go and upgrade your Kubernetes version. So all those management overhead that you had typically when you want to run an on-prem Kubernetes cluster, and trust me, it's not that simple. In fact, there is a certification just on running those Kubernetes cluster called CKA, Certified Kubernetes Administrator. And there are a lot of things you have to worry about. You have to worry about the high availability of the HCD database, which is the centralization store for everything Kubernetes, right? It's basically storing all your information in a name key value pair kind of format. Just making sure that that thing is highly available, the certificate management between the worker nodes and the master nodes, working with controllers and all those stuff. Well, that's too much of a pain, right? In such scenarios, you can take advantage of AKS or Kubernetes, right? So I already have an AKS cluster created. Now, the good thing about Kubernetes is we'll give you a managed cluster. The way you want to deploy your applications, whether you want to use a Helm chart or you want to simply use a standard YAML-based definition that goes through a pipeline and deploys those applications. You want to split your namespaces across. You want to basically have security on top of that. You want to take advantage of Azure policies versus Calico policies, all those networking policies. You want to make sure that you have security built in using Azure AD's RBAC. All those capabilities are just baked into the product, right? So here I am going to go to the AKS cluster that I've already created. Now, this one is that AKS cluster. All right. Now, if I go back to my command line here, hit Control L to clear the screen, notice that if I run kubectl, by the way, so if I run kubectl config get context, you'll see there's an asterisk here for Docker Desktop because that's what is currently configured here. Now, if I wanted to authenticate myself to this Kubernetes cluster, AKS makes it extremely simple by using an Azure CLI command. So I can simply run az AKS get credentials, and this will basically go connect to that particular Kubernetes cluster and save that context in my local kube file, which it's already done. So you notice I've already authenticated to that particular thing. Now, still, if I go back here and do a Control L, and if I look at, let me actually get rid of this, and if I do a kubectl get nodes, it's still showing me the Docker desktop because currently the current context is set to my Docker desktop. If I actually go to my node pools here, you will see that I have one agent pool and I'm using auto scaling, by the way. So it's currently scaled to 1 instances. I can scale between 1 to 5 or depending upon how many instances I want to choose, right? This is typical standard DS2 V2 instance. It's running Linux. We're using Kubernetes version 1.21.9. All right, so let's go back to our cluster and let's switch our context to this cluster. Okay, now, even before we do that, we can basically go and execute some commands locally on Kubernetes. But again, this is not just a Kubernetes session. So I just want to make sure that you are aware that I don't need that particular AKS cluster to test my Kubernetes experience or my environment, I can just use the Docker provided Kubernetes cluster, because with Docker, all I actually get here is a single node Kubernetes cluster that includes the master plane and the worker node. All right, beautiful. Now, let's meditate on this fact that now I'm going to switch context to the AKS environment, right? So I'll go to kubectl config. I'll use the context of the RTO, in fact, the RTO AKS cluster, right? So now I'm switching the context. So if I go back and use the previous command, which is get context, notice this time the asterisk is to the AKS cluster that I have created. Now, this is interesting because now if I go and hit Control L and do a kubectl get node, you will see that now I have an agent pool node. Beautiful. Okay. All right, beautiful. So what we have done is we've authenticated to our Kubernetes cluster. Now the steps are the same. That's the whole point of using Kubernetes, right? Whatever I could do locally on my Docker for desktop using Kubernetes, I could experience the same stuff on Azure. The only difference is now I'm working on a production cluster, so to speak. Obviously, in production, you'll use a CI/CD pipeline, make sure everything is proper. But in this case, we're just connected to the AKS cluster interactively, okay? Now, I want to basically deploy an application on this particular cluster, and we already saw some of the images that we have. What I've also done, by the way, is I have used or linked this to the Azure Container Registry that we used in the previous demonstration. Okay, and your question would be, that's great, Manoj, but again, how did your Kubernetes cluster or AKS service get the ability to pull images from ACR? Great question. We'll come back to that in just a moment. All right. So Control L, let's go and create a deployment. Now, I don't expect this to be a Kubernetes session, but think of this as when you run container instances, when you run containers within Kubernetes, you typically deploy them into pods. Now, you don't typically create pods that by themselves. You actually use a wrapper called deployment, which actually is a wrapper on something known as a replica set. So I'm going to create a deployment, right? And then we're going to expose this deployment as a service. Think of this service as a load balancer, so to speak. And this service will basically allow me to go and connect to those resources, so to speak. Okay. Now, when you're doing this locally, your service could be of type node port. So basically, you're trying to connect to the port, a host port, which is an ephemeral port, let's say 32,000. And that port gets mapped to the container port. That's because you're running it locally. If you actually go and run this in a cloud environment, there is an additional controller that's created called the load balancer controller. And that controller basically looks in for any service and creates a load balancer for you behind the scenes. In Microsoft Azure, that load balancer is a standard load balancer. Okay. So first, let's create that deployment, right? So I'm going to use interactive commands here, but you can always use your YAML or Helm charts or whatever you prefer. So let's use kubectl create deployment. I'm just going to go ahead and specify this. So it's creating deployment called my app v1. All right. It's using the image that we used earlier, the RTO ACR01.AzureCR.io. Remember that my app created the image that we created. And we're going to specify two replicas. That means at any given point of time, I want two instances, so to speak, of my application up and running. Okay. So let's hit enter. And now it creates a deployment. All right. So let's go to kubectl get pods, and I'm using the wait switch here. So both the pods are up and running. Beautiful. All right. I have a deployment now. The question is, how do I interface with this deployment? How do I connect to this deployment? The answer to the question, as I said earlier, is a service. One such answer is basically service, by the way. So a service essentially is that load balancer component, right? So if I just do a kubectl get pods -- all namespaces, I want to see all the pods. You'll see that apart from the ones that I've created, there are a bunch of system pods that you can see. And these system pods basically correlate themselves to the actual underlying Kubernetes cluster components that make this Kubernetes up and running. Things like the DNS server, the metrics server, the disk node basically allows you to authenticate to different, if you want to mount storage volumes and stuff like that. You have an Azure IP service. So all these things are already in place, up and running for you in order to take advantage of this different ecosystem of services that Azure has to offer, right? I'm going to hit Control L. Now, so we have our pods up and running, as you can see. Beautiful. Now, let's go ahead and connect or create a service. Now, one way to create a service would be to use kubectl expose deployment. I can say my app one, and I want to use the type of load balancer. What I also want to do is to map the port 80 of the container to that particular load balancer. So it actually creates a load balancer for me. And then it also creates a load balancing rule, which says any request coming on port number 80, I am going to take this request and connect to your backend system, which in this case is a service. Now, for your information, the service is actually not a physical construct as such. It's a virtual construct, right? Technically, behind the scenes, we use kube proxy to do all those magic for you behind the scenes. And I haven't spoken about the amazing benefits where this Kubernetes cluster is actually running within a virtual network. I'm not even running this directly on the internet. I'm running this within a virtual network. So you can even basically have a private Kubernetes cluster in case you don't want to expose your web applications on the internet, or you want to basically have some kind of a governance, so to speak, before the traffic enters your network. I'll show an example of that later. All right. So let me hit enter. So now I've exposed the deployment. Now, what that does behind the scenes is, if I go back to, by the way, if you're tired of typing kubectl, you can create an alias called k for kubectl. So you can just do a k get pods or k get services. So if I just run a kubectl get service, by the way, get service, you see that now I have a service created. That service is of the type load balancer, and it is using this public IP address. All right. Let's go to this public IP address. So I'm going to copy this public IP address right here, and let's navigate to that. Control V, hit enter. Okay. So hopefully, if my application has worked successfully, I should have this IP address resolved to my application. And it does take a bit of time for it to do the health checks and the probes and stuff like that. So let me actually navigate to this Azure AKS cluster while loads the application. And I want to show you that in that resource group, so to speak, which has this container, the AKS cluster, you won't see any load balancers. There is no load balancer here. So where do you create that load balancer? Is it something that Microsoft managed for me? The answer is yes, we do manage for you, but we actually manage this in a management control plane. And that management control plane is hosted in a resource group. If I go back to resource groups, called a management control plane, followed by the resource group that you used here. So if I go here and click on this application, or this resource group, you should see that load balancer created, this standard load balancer created here. That is the Kubernetes load balancer. And in the front-end IP configuration, you will see that this is indeed that IP address of that application that I created. So this is where you have that rule created. And there's a rule that basically maps that port to that particular port. Okay. All right. Now, you will see that in this case, I can't connect to my application. Interesting. What's happening? So let's do a refresh again, and it's still not loading. Now, this might be a scenario where I'm trying to pull an image, so to speak, and it's not able to pull that image. In fact, let's try to see if we can fix this, right? So I'm just making sure that I have time. Yeah. So I'm going to say kubectl, okay, describe. If I like to do a get pod, I probably know the reason why. I'm going to copy this here, this pod here, and just do a kubectl describe pod, and I'm specifying this here. Now you can see that it started my app, but then it's unable to load that application. And one of the possible reasons for that process, let me in fact check the status of my service as well, would be the network security groups. Okay, we'll just come back to that. So let me do a describe service and my app v1. All right, so this looks to be ensure load balancer. It looks to be okay. Let me maybe try it again. kubectl get service, and I need this one here. Okay, let me open this up into an infrared window and see. Okay, we probably will fix this a bit later. In the interest of time, I probably have to troubleshoot what's going on there, but ideally it should not. In fact, let me do this. Let's do real quick a kubectl edit of that deployment that we just created. Was it my app? Was it my app v1? Now, if you do a kubectl edit of that particular deployment, notice that it opens on a Windows machine, it will open up a notepad file. On a Linux machine, it will open up a command line terminal or Vim. In this case, I'll just scroll down here and change this image to, let's say, Manoj Nair / my app : V2. Let's do that. In fact, V1. And I'm going to save this file up and close. And if I do a kubectl get pods -w, you should see that it's now deleting the older pods and creating those 2 new pods. Remember, the replica set that we created was 2. And this is all terminating. Now it's just killing off those older pods and making sure the other pods are there. Control C. Let's do again a kubectl get pods, but I'm going to remove the so it's up and running now. And if I do a kubectl get service, you'll see that I have that IP address here. Let me try that again. It's of type load balancer. See what happens. I copy the right IP. No. What am I doing? Copy, paste. And this, hopefully, once it registers, should be able to launch that particular application. So we'll see that later and debug this later and what's happening, to be honest. I'll have to see what's going there. But the load balancer is a standard load balancer. It's a layer 4 service, right? What if you have a scenario where you want to take advantage of layer 7 routing? In such scenarios, you can basically take advantage of an ingress controller. Okay, an ingress controller is a layer 7 construct. Now, you could use things like Nginx and stuff like that to do so. I can also take advantage of a service that we have within Microsoft called Application Gateway. So basically, you can have an application gateway that can serve as an ingress controller. So you have an application gateway, which is a layer 7 load balancer in Microsoft, that basically goes ahead and connects to your Kubernetes cluster. And any changes that you make within the Kubernetes cluster just seamlessly transfers over to the application gateway. Okay, so let's take a look at that. I'm going to close this off because it just didn't work. Very interesting. And by the way, if I can always go back to my resource groups here. And again, this would be a great thing to check your log files and what's actually happening. But obviously, that troubleshooting, I don't want to do right now in the interest of time. But if I go back to the resource group here, and I look at my Kubernetes cluster here, AKS, you will see that I can see all those information here, like the namespaces, the workloads, the services, and the ingresses and stuff like that. Okay. Now, let me go back here, hit Control L, and if I show you something like kubectl get ingress, right now we don't have any ingress controllers. Okay. I want to create an ingress controller. So I'm actually going to go back and copy a command that will create an ingress controller for me. Okay. An ingress is a layer 7 load balancer. So this one here actually creates an application, and a pod, a service, as well as an ingress controller. So if I now do a kubectl get service, you will see that I have one more service, which is this ASP.NET app, and it's running on this cluster IP. It doesn't have an external IP, but if I do a kubectl get ingress, though, this one has a public IP. Now, if I copy this one here and I paste this to my application, you'll see that this actually worked, and thankfully worked, and it gives me that application here, right? Notice that this one here is not secure because it's an HTTP connection, right? But what has this done behind the scenes? What I did is, if I go back to my cluster and I go to networking, right, you will see that one such option that I enabled in my cluster is called Application Gateway Ingress Controller. So this will actually create an application gateway for me. And that application gateway gives me the best of both worlds. Now I can do things like SSL termination, where I can terminate my SSL connectivity at the application gateway and then send the request just on plate number 80. I can do things like WAF, the web application firewall on my application gateway. So if I go to my, by the way, if you go back to that resource group, again, you will not see the application gateway. So where is it creating? It's creating in the same MC group that we saw earlier. So if I go back to MC RTOG, you'll see that this is where it has created that application gateway, that app gateway. Now, right now, we are not able to get that, secure layer. So let me actually go and fix that for us. So I will go and first look at the listeners and see what we have. Okay, we have an HTTP listener. So I'm going to add a new listener. And to add a new listener, I need to give it a name. Let's call this the uh, ASP.NET app. The front-end IP is the one that we already have on our app gateway. We want to do this HTTPS. All right. Now, I'm going to use a domain called request timed out, for which I already have a PFX certificate. You can integrate this with Let's Encrypt and all those stuff as well, but I already have a certificate. I'm going to select existing, and I'm going to choose an RTO certificate that I used in my previous demonstration, not this one, but the previous one. And I can choose to go with multi-site. And here is where you can take advantage of the SNI, the host name feature, where particularly host. So you basically can have multiple services running on port 80, but based on that host name, you can say, if you go to app dot or ASP.NET dot request time dot in on port number 80, I want to send you to this Ingress controller, and this is where you need to go and fetch your data from, right? So here I'm going to go and say multiple, and I'm just going to give it a name. Let's call this Michael dot request timed out dot in. Okay, that's going to be my domain name, and I'm going to click on add. Okay, so what I've done now is I've added a listener. So something that listens to that request coming in on the app gateway. And now I need to make sure I can map it to the right backend. To do so, I need to go and write a rule. Okay, so let's create a rule where we'll say that, hey, connect to ASP.NET. The listener is going to be my ASP.NET app. The backend target is going to be that pool that I created. And notice that the integration between AKS and application gateway is so well done that it automatically creates that backend pool for you. So I want to say that, hey, I want to use this backend pool and I want to use HTTP, because remember, from the app gateway to your AKS, I just want HTTP. Now, of course, if you want to have end-to-end SSL, you can do that. In this case, I don't want to do that, right? And then I can click on add. That's it. So that creates that. Now, we still haven't fixed this issue because we have provided domain name, okay? And this is that IP address, so to speak, of my Ingress controller. If I go back here, you'll see this is the IP address of my Ingress controller. I'm going to copy this here just a moment. And let's go to our resource groups. And I have an Azure DNS service, so to speak. That DNS service here has it's called request. It's a public DNS zone called request timed out.in, for lack of anything interesting. I'm going to create a record set, and that record set is going to be Michael. Remember, that's what we put our domain name as, and I'm going to provide that IP address here. Now, depending upon how soon the replication happens, assuming that it's quick, so we have that record created. Now, if I go back here and change this to Michael dot request timed out dot in, it should actually go and run this. Now, it's still showing me not secure, but if I change this to https:// you'll see that now we have a application that's secured using HTTPS, but running on AKS, front-ended through an application gateway. Okay. Now, think of this for a moment. You had to create pods, you had to create services, you had to create ingress controllers. You then had to make sure that you could write some scaling rules to scale your resources up and down. What if I tell you that I can give you one simple technique to do whatever you can do, not whatever, basically most of the stuff that you can do with Kubernetes, but in a completely, truly serverless fashion. And one such service is the brand new Azure Container Apps, one of my favorite services, by the way. So if I go back to my resource group, let's choose this one here. I know we have on time, just give me 5 more minutes and I'll complete this, right? Let me click on create, and I'm going to start with a container. And my friend, this is actually going to be a game changer, because what this basically allows you to do is take advantage of not only the Kubernetes environment, but also something known as KEDA, Kubernetes event-driven architecture. And what that basically allows, by the way, my portal expired. Interesting. All right, let's connect here back. All right. So it not only takes advantages of that Kubernetes environment, but also event-driven architecture using KEDA, that is Kubernetes event-driven architecture, and also a service for building microservices called Dapper. Now, if you haven't heard about Dapper, and if you're in this business of creating microservices, have a look at that. It makes creating, managing, and deploying microservices very, very easy. And the fact that ACA or Azure Container Apps can tap into Dapper as well as KEDA opens up a lot of opportunities. Think of this. you have something running on an Amazon SQS queue, and depending upon the number of messages in the queue, your application, which is hosted on Azure, needs to scale up and down. Today, you have to work with a lot of webhooks and Lambda functions and your APIM and blah, blah, blah. What if I tell you that there is a webhook available, which basically you can subscribe to? And depending upon the events that happen there, you can basically go and scale your applications up and down. Not only that, you can even scale to zero, so to speak, so that you don't get charged much for your applications. That's where ACA comes into picture. So I'm going to create a resource real quick and show you how simple it is to use ACA. This is a portal experience. You can do the same using things like CLI or obviously Bicep and other infrastructure as code. So we'll go to containers and choose to use a container app. I'm going to click on create. And now it just prompts me for what subscription do I want to use. Now this is showing me all my subscriptions. And if I go back to my dashboard here, I'll just make sure that I switch to the right filter. Let me just navigate back to default, internal subscriptions. Beautiful. Let's go back to our resource groups. And here, let me create a new resource. We'll call this, let's go back to our containers and choose to use container app, which is preview, by the way. I need to choose a resource group. Let's choose our RTO01, and I'm going to give it a name. I'll call this my app v1. Okay. Now it's going to load a container environment. Think of this environment as one single hosting environment, just like an app service plan view, where you're going to host all your containers. Typically use an environment for one application. So one application, one environment, which have multiple containers. Now, the advantage between this is you can invoke those resources using things like Envoy and proxies and stuff like that. So I'm going to create a new environment because I don't have one. And this is where you define the environment name. So in this case, I'll just call it my app env. And I'm going to define this in, let's say, in this case, let's use East US. And I click on, by the way, let me make sure that I click on monitoring. You can add it a monitoring workspace. You can choose whether you want to deploy this within a VNet, have access only within a VNet, blah, blah, blah. In this case, I don't want to do that. So I'm going to click on create. So notice that now you can create that ACA, which is basically creating an environment for me. And now you just basically get a serverless environment to host your application, similarly to what I did earlier with using Kubernetes, but I had to do a lot of stuff myself. What AKA or ACA also allows you to do is to basically take advantage of revisions. So if you want to do traffic shaping, let's say 80% of my traffic goes to, my version 1, and I'm introduce a new version of my application. I want to spend the remaining 22 on those remaining 20% on the other application. You can do that as well. So this is actually deploying the application, and you will see how simple it is essentially to run those environments, to run those containers within that particular container, Azure Container App. Now, highly recommend to have a look at ACA if you do not have that Kubernetes experience, but obviously you don't get the full scale of Kubernetes there. It does come up with the advantages and the hooks that you can take advantage. For example, a deployment revision is carried forward as revision. You can take advantage of Dapper. You can take advantage of Keda. So all those features are built in, and it's a preview. We'd love to take your feedback about that particular service. What I've also not covered in this session today is some of the other orchestration platforms. Now, if you are a Java developer on the call and you've written applications in Spring Boot and stuff like that, and you want to host those applications on a Spring Cloud, we have Azure Spring Cloud that you can look into. It also supports containers. If you come with an OpenShift experience, then you can also do that as well. Where with OpenShift, if you're running OpenShift on premises, you want to move to Red Hat OpenShift on Azure, be my guest, you can do that as well. There's another service called Azure Service Fabric, which kind of underpins a lot of Azure services. If you come with a .NET or a Java experience, you have written applications using reliable actors and reliable patterns. In that scenario, you can take advantage of Azure Service Fabric. But we know that the world is more geared towards thinking using like Kubernetes, and of course, ACA could be one such example. As I said earlier, orchestration-wise, you can also take advantage of ACA. So my resource has completed, by the way, deployment. And you will see that this is where my application is. So this is where that standard application that I can create. Now I can choose to create an ingress controller. Remember I talked about the concept of using application gateway as an ingress controller. This just does it for me. It just handles that ingress for me, creates that ingress controller for me behind the scenes. And I can actually go and connect to this application here. And it basically gives me this welcome to the container apps. Now, what I can also do, and I promise this is going to be the last thing, I can also go and now create revisions. Now you see that there is one revision here already created. I can create a new revision. Notice that I'm creating a new revision. And I'll give it a name, call this V2 for lack of anything interesting, or V2. And I'm going to add a new container to this. Let's call this my app V2. I haven't shown you V4, right? Let's do V4. It's going to be on Docker Hub. It's going to be Manoj Nair / now obviously it could be an ACR, my app :V4. And I don't want to run any other commands. CPU core, let me give it as one CPU core with 2 GB of memory. If I want to add environment variables, that's fine. And I don't want this anymore in the revision 2. So I'm going to get rid of that, and I'm going to click on create. So I'm creating a separate revision, so to speak. This is a brand new version of that application. So this is the application version running currently, which is welcome to Container Apps. And if I come back here, you will see that that revision has been created. Beautiful. Let me actually refresh. So it's successfully deployed. So let's refresh that. And now that revision is up and running. Okay. Now, here's something interesting. Right now, 100% of my traffic is hitting the revision 1. Both are, by the way, you can take one offline. You can take this offline. Right now, both are active. Okay. So if I actually navigate to this here, open this up in a different tab, you'll see that this basically will have that same URL, which is revision 2. So if I copy this here and take it here, in fact, let's do a different tab here, paste it, you will see that other application that I have, right? Now, if I go back to, in fact, the first application, I just clicked on revision 1. So if I go back here and choose to go back to the revision management, I can change the 100. By the way, did I delete the wrong person? Hold on. Anyways, might have done that. I'll have to check whether I did the delete the wrong revision, but that's fine. You get the point, right? So I'm going to click on save. In fact, I'll double click on this. So you can do traffic shaping, so to speak, between them. Okay. Yes, I did that mistake. I deleted the wrong version. But you get the point, right? Essentially, you're shifting between the two revisions. So maybe what I should do ideally is to create a new revision. So I created a new revision and I deleted this revision that I created. You can use the older one. Bad thing. But you get my point. So now what you're basically doing is you can shift the traffic between 50%, 50%. If you're interested, I can do it in just a moment. If not, I'll take questions. But while I take questions, or while Michael jumps in with questions, I'll just quickly create one just to show an example of that.
There's no additional questions, but so we'll just give you a minute to show your final thing. But it's been a very informative session, so thank you. For those joining us still, there is some links to some Microsoft Learn modules that support the session that Manoj has just done. So I encourage you. Oh, here I have a question here. It's just popped up. Okay. Can each of the apps have private endpoint if there is requirement?
Is that question for AKS deployment, or is it for an ACA deployment?
We'll just have to wait for
I'll just give the answer for both, then it's easier, right? For AKS deployment, yes, pretty much straightforward. Remember that Ingress controller that I created, that Ingress controller can be completely running within a private network. So you could have an application gateway, if you use application gateway Ingress controllers, run within a virtual network. So it would have a private endpoint. If you're talking about ACA, notice that there was a feature where you could say that, hey, I want to make this public, I want to make this private. So when you do this in private, essentially that endpoint gets created in the VPC itself, in the virtual network or the virtual private cloud that we have within the Azure. So that's the advantage of using that private network. So that's obviously a question that you'll expect a lot of customers to ask, saying that I want to have a private endpoint, and that's something that is supported currently.
Yeah, it was in the ACA, so thank you for answering that. We have another question. Can one add Prometheus as container with this?
Yep. Now, you can add Prometheus as containers with this. The advantage, though, that I would say if you use the native monitoring solution, especially the Container App Insights, is that will give you a built-in integration with a lot of monitoring capabilities. So potentially whatever data that you could potentially get with Prometheus is something that you can automatically gain with application insights for ContainerWorks, because that's technically defined or designed just to do that. But nobody's stopping you to use Prometheus.
Fantastic. Well, I think that's all the questions, Manoj. So if there's anything else you want to quickly show, by all means. Otherwise, we will wrap up. And this session will be available on YouTube, as I've shared, for people to go back and watch. We've just had one quick thing pop up. The reason is for legacy apps where App Insight does not support.
Okay. For those legacy applications where you have no application insight support, maybe it's because of those SDK insights, SDK compatibility. You're right. In such cases, you can use Prometheus as a way to monitor that data. Remember, at the end of the day, this is just Kubernetes behind the scenes. So you can basically have a sidecar container pattern, like a Prometheus one, as you said, to do that, downstreaming monitoring of data as such.
All right. Well, we will stop there. And I want to thank Manoj greatly for his time. It's been an absolutely incredible session. I trust that all of you who joined us live got something fabulous out of it. This, as I said, will be on YouTube, and there'll be many more views during that. So without further ado, I will thank you again, Manoj, and wish everyone a wonderful day, evening, or morning, wherever you are. Thank you, everyone.
Thank you so much. Thank you so much, Michael, and good evening.